Can you see the screen?
Yeah. But it will be better if you can like share a screen, not the file. You are sharing the file so that people can jump to another page. Um,
Actually, I have.
cool. So yeah, we are ready. Look. So, um,
Just for instance, I would like to know from the participants where they are able to see the chat section or not. We'll be just starting in 5 minutes. Please be patient and wait for a while.
Cool, got it.
All right, so we should start. So hello everyone, this is Megha Pandey, the Microsoft Learn Student Ambassador. And other than that, I am a diploma student at Computer Science Engineering field. I'm from Jamshedpur, India.
Right.
Yeah. So let's move ahead. And one of my friends, I'm co-hosting this event with one of my friends. He's from Taiwan, and his name is Mark.
Hi.
Mark, would you like to introduce yourself?
Welcome to this event again. My name is Mark, a computer science student as well as a Microsoft Learn Student Ambassador. To welcome you guys to join this event. Today we're about to share a lot of exciting news and content about Microsoft technology and sport exploration. Welcome you again to join this event, and stay tuned for what's coming up. All
Awesome.
yours.
So
Okay.
we are going to talk about space technology. It's the most interesting event nowadays, and because of that, the world is coming into an era where space is going to take the world. I know the words could be so much chaotic, but the meaning is that once we are going to capture the Earth, we are going to move up to the space, and that's the main basic point of this event, basically. So let's move ahead. So we're going to talk about what is a spacecraft, the type, cost, mechanism. These are all kinds of things we are going to start up with and start our space journey with. All right, so you can see the screen shared over here. I hope it's visible to each and every one.
Yeah.
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 Thank you very much. So all about spacecrafts. So everybody is curious about what is a spacecraft, what is a spaceship, a space shuttle, and kind of thing. So they are not different things. They are one thing, and that is a device that carries you outside the Earth, the atmosphere of the Earth. It is like a huge machine or a device which carries you out of the universe. It can travel anywhere. It's called a rocket. It has got different names and different
Right.
it has got different.
Cool.
Can you hear me?
Yeah, sure.
Awesome. So it has got different names like spaceship. You must have known about Starship, one of the most famous one currently, but we'll talk about it later on. First, the meaning of spaceship is what? A device that carries you out of the Earth. You can travel it from anywhere because it contains oxidized air and oxidized agent inside it, which carries you to one place or the other. Basically, thing is that spacecraft, spaceship, rockets, and space shuttles, they are all one. You can name it anything. And the thing is that what's inside the spacecraft? And everyone is curious that what actually the spacecraft, the spaceship, whatever you call it, I will call it as rocket. So what does a rocket contains inside? It has got basically three parts: the payload, the guidance system, and the propulsion system. Okay, so I'm going to explain you with this diagram particularly. You can see over here this one. This one is a propulsional system. I will write it over here, the propulsion system, because it is a major part of a rocket, which carries the rocket to the space. It contains the fuel, which is very important for the rocket to fly over. Over here, it's a rocket from from NASA. So it has got different parts. this is called the boosters. Okay, and this is the payload system where all the data, like if you are carrying a human, the satellite or the missiles, they are placed over here, this side. These are called the payload systems. The guidance system always contains all these computational processes, the programs, the sensors and kinds of things, which take you or redirect you to the main hub, the main center of the organization from where the rocket is actually launched. So basically, the fact is that when a rocket is launched, it's something like this kind of thing. If I'm not good at drawing, I know that, but it's something like this. Okay. So whenever you would have seen a rocket launching system or a video. So you see that as soon as the rocket is launched, it tilts a little bit down. So what is that tilt? The tilt is called gravitational turn. Just because of the fact, that every action has an equal and opposite reaction. Yeah, we have learned it from the childhood, this kind of thing, okay? So what happens actually is whenever a rocket is launched upside in the perpendicular way, in the side, up perpendicular to you. So what happens is that due to atmospheric pressure, a lot of atmospheric pressure is over to the rocket. So what it does is that we turn the rocket just because the fuel will get over and the rocket will fall. And we really don't want to fall our rocket in between. So we are going to launch our rocket that is Aqua. It's basically a rocket or, a spacecraft, you would say anything. It's a satellite name, but I would like to name it as Aqua. Our rocket name is Aqua. I've written here. So welcome to the world of space once again and start our journey with Aqua. The Aqua contains payload, guidance system, and proportional systems, which I have told you earlier. Okay, so let's move ahead. If you have any kind of questions, please feel free to ask me or ask Mark. Awesome. So if we are launching a rocket, we should know the cost, the type, the mechanism, and what is deep space. It's just an interesting fact I really love to know. So that's why I started out with this. The cost of taking a rocket to the space is around 50,000 US dollars. Okay, 50,000. I haven't written the whole world, but it's around 50,000 for 1 kg only. So you can think about the weight of the actual rocket is around 4.4 million kilograms of pounds. We can say that. So you can imagine what is the cost of a rocket. Since it has declined a little bit too, because there are so many innovations going on into the space and kind of thing. So we have got a little bit lower. That is currently, this cost is around 2,000 US dollars per kg transferring to the space. And the types are, there are 3 major types of rockets. The major one that carries human beings. Second, that carries the satellites. And third, that carries the missiles. There are 3 major types, okay? So we are going to learn about these kinds of things in the later folder. I hope that's clear. Okay, so here is the brief thing. So we got to know about the cost. It's like, I will just mention over here, it's $4.4 million, US dollars, according to the statistics, what we found, and it's very heavy. So is anyone interested to know the weight of a rocket? You can raise your hands right over here, or you can just unmute yourself and say if you're not able to.
Yeah, yes, response. You're interested in
Awesome. So the actual weight of the rocket, according to the people belonging, is like 150 pounds, million pounds, I would say, is the you can say 150 million kg. So it's quite heavy. So you can calculate in your calculators later on that what should be the cost, the actual cost of launching a rocket, which actually contains stuffs like payload system, the gas tank, and kind of thing. So there are basic 3 types, as I said earlier. Thank you very much for your responses. You can put down your hands. And again, let's have a brief introduction to what is the communication. So I hope there is no any kind of query till what I have taught you, like what I explained you till this. Okay. So if you come up with questions, feel free to ask me on the chat, or we will give you a chance to unmute yourself at the end of the event. So let's move to the next slide, and that is how the communication takes place between the space and the Earth. So the word space is used to be such a huge word, space, just the word of 3 or 4 words, but it's actually, it has got a huge meaning. The whole universe is just in between the space, inside SPACE. So how do we communicate with our satellite, our rocket? We have got our Aqua released just now. So how we are going to talk with our Aqua? So basically, on Earth, we have called these kinds of devices. I think you are able to see these kinds of devices. These are called ground stations. These are called ground stations. Now, I am not able to write the whole name, but I hope you are able to understand. These are called ground stations, and these are like huge discs, a very giant disc, placed at each and every places right over here at different paths. So these have a special type of sensors attached to them, through which they are able to connect with the antenna of our payload. So you know that our payload system and the communication system consists of a small device called the antenna, which is, connected with, awesome. It's called the ground stations. Mark has written over there. So it is going to communicate with our device, that is the ground station, which is connected to our central hub from where we are launching our, satellite. So basically what you have to do is that we have to take a cost of these, and these cost a huge amount. They are very complex, as well as they cost a huge amount. And again, what we have, another thing is that we have got, there are a lot of satellites launched all over the Earth. So you can't see them, but they are actually one. You are always responsible. You always think about the thing is that you have launched a satellite. You see the picture, you see the video on the screen, on TV, and then you forgot about that. But what is the internal mechanism going on over there? You really don't know about that. So here we are going to just explain you what the actual things takes place over there. Over there, what happens? We have got, let me erase that, created a mess over here, completely the mess. Sorry. Okay. So over here is our huge Earth. Our rocket is somewhere right over here. And these, at some places of the Earth, they are called ground stations. These are ground stations. They are attached to the Earth, and they are placed at some or the other places just to communicate with our satellite. Our satellite is something like this, flying over on bridges, and at the speed of like 6,000. It's 600, it's so small. It's called 6,000 kilometers per hour. Okay. So it's going with that speed and it's rotating into our orbits, which we are going to tell in the later slides. But for that, for instance, I will just explain you about these. The satellite has an antenna and which is connected with a small satellite right over here, and which is connected with a ground station. So it's a kind of huge mess right over here. But just for instance, these ground stations are very, very important for each and every space to get communicated with. So I see any hand right over here. Do you have some questions, Janet?
Can you please elaborate the communication? How is possible? Means satellite and this type of antenna, how communicate each other? Can you please
Okay,
elaborate it?
sure. So just for a brief instance, if you're not able to understand with that, I've got a simple thing that is like, this is our Earth, and from the Earth, we have got some places where we install these kinds of ground stations. These antennas or the disk you see over here. These are called ground stations, and they are actually having some kinds of sensors. Your satellite is over here. From the hub station, here is the hub station from where you launched your Aqua. Okay, this is the substation from where we launched our spacecraft or the rocket. So it went over here with a speed of like around 30,000 kilometers, something like that, and it's rotating to the Earth orbit. So how we are going to communicate? From our substation, we have got some devices that are connected with these ground stations. Okay, these specialized ground stations actually consist of some specialized devices which are able to connect with our spacecraft or our satellite right over here. Okay, and there is a kind of beam or the frequency that comes over. The data is communicated between these and these two lasers. You know about the fact that how laser pointers points to a particular thing, like, so they have got a very well designed antenna. We can call it as antenna because from where the sensors direct or eject some kind of information to the ground station right over here, and then the ground station process that data and send back to our data centers right over here. That from where we actually launched our rocket. Okay, I think the part is clear to all of you. Now about orbits. All right, awesome. Now what we're going to talk about is the orbits. Orbits are very important. They play a very important and huge role in communication and also in the rotation. So you have seen a lot of satellites rotating over here, anywhere, some around the Earth. So they rotate on an orbit. That's called an orbit. There are basically 5 kinds of major orbits. These are LEO, GEO, MEO, and these are aligned in such a way: 1, 2, and 3. The first one is LEO, the second one is GEO, and the second one is MEO, and the third one is GEO, and this kind of thing. And the other 2 are sun-synchronous. Sun-synchronous. I can't write the whole name, but Mark, would you like to write them on the chat so that people are able to,
Yeah, I'm writing down on it, so you can take a look. You can take a look. We got inspiration and reference for low Earth orbit, LEO, and our orbit. You can take a look. Yeah.
Thank you very much. So we got 3 spatial orbits aligned to like 1, 2, and 3. So the question comes over here that if only these kinds of orbits rotate around the Earth, what about the perpendicular one or the longitudinal one? So we got the the fourth one and the fifth one right aligned like this side. These are sun synchronous and Millennium. I don't know if the name I pronounce is correct or not, but it's something like that.
Cool. Mike, are you here?
Yes.
Are you there? Okay, cool.
I think there is a problem. Okay.
Cool.
I got it. So we got like 5 kinds of orbits. I told you right now. The fifth one is Millennium. YLONIA. Okay. So it's only about the orbits where the Earth, the satellites actually rotates. There are a lot, but the major are these 5. I hope you are able to understand what I'm trying to say. And into the deep space. So it's very interesting fact about deep space. I would like to tell you all that whenever you know that the Earth is something like this. Okay, I know I'm very bad at drawing, but just for instance, I'm trying to tell you all the Earth is something like this. And then we have got some satellites placed into the million kilometers. Okay, the satellites which are into the million kilometer devices are called as the satellites near to the Earth. But after that, some satellites are even more deeper into the space, into the universe. Just like an example of Voyager 1. It was launched, in 1977. Voyager 1. It's in the speed of, at present, it is in the speed of something like 162,000 kilometers per hour. And it's just vanished into the space. People don't know about that. But for casual, if we are sending any data to some of the devices or some of the rockets, I would say, into the deep space, it is connected with deep space network. So we have got a different kind of antenna installed into it. I hope the recording is going on. Mark?
Yeah. Yes, the recording is going on already. Yes.
Okay. No problem. I was just curious about that. The thing is, it's deep space network. So how do we communicate with our spacecraft into the deep space, like Voyager 1, if we had something, if our Aqua goes into the speed of something like 1,600 and kind of kilometers, and it's in the distance of billions. Under the area of million kilometers, it can be set into the orbit of Earth. But after that, it's called into the deep space. So if by mistake, if we are launching our rocket called Aqua and it goes around into the space and it vanishes away to the million kilometer distance, then we will call it as deep space network. A deep space, into the deep space. The satellite is into the deep space. And we have got another mechanism to talk or to communicate with our devices right into the deep space. Okay? It is something like this. Into the Earth, we have got 3 major ground stations placed at Australia, America, and Spain. They are like 120 degree at a distance of 120 degree. You see? And they have got special kind of ground stations with the antennas attached to the ground stations are like they have laser pointed communication system through which they actually communicate. So one of the satellite or the rocket which is up into the space and it has actually vanished is called the deep space network, and it is Voyager 1. Just for instance, I'm trying to tell you all. Hope that's clear to you, each and every one.
Yeah.
Now, the quiz time. And I want to each and everyone right over present over here to answer these two questions. What is the weight of the rocket? If you're listening quietly and concentrately, you will be able to answer these questions. And I think the chat is available for each and every participant. And if not, please let us know.
Feel free to leave a comment in the meeting chat session so that we can see your answer. And yeah, if you've got any question about this presentation software, feel free to bring out in the meeting chat.
So if you're not able to access the chat, you can raise your hands and I will unmute you and you can answer the question. And don't Google it. Okay. So we got one. It's Shreya. Shreya, would you like to unmute yourself and say the answer?
I think nearby 3 million. 3 million.
Yeah, it's approx good. So the other question, what is the full form of NASA, ISRO, and JAXA? JAXA. I only see one hand. You can answer one of the question or the two. It doesn't matter. Okay, Vivek, would you like to unmute yourself and answer? Okay, Jenna, please go ahead. Anyone out of these two?
NASA stands for National Aeronautics and Space Administration. I think this is the right answer.
It's administration, or it's called agency. Anyways, it's approx correct, so clap yourself. And Vivek, would you like to unmute yourself and answer?
The full form of ISRO is Indian Space Research Organization.
Awesome. So about JXA, is anyone familiar with that? So I see Roshni, would you like to unmute yourself and answer this question? Or anyone out of those who have already answered?
Yes, Japan Aerospace Exploration Agency.
Awesome. So I think people are actually listening to me and I'm very happy. And thank you very much for joining. At the end, I'm going to thank you all, but just in advance that you're listening constantly. So thank you very much. So let's move ahead. Mark, would you like to add something if you really want?
No, so far.
That's okay. No problem.
Okay.
Okay. Now let's start our Azure journey from here. So everybody is curious about what is Azure. You must have heard this name into my, when I was introducing you all to my introduction and then another kind of thing into the flyers and kind of thing. So Azure, as you can see, it's here. The Azure Cloud Platform is more than 200 products and cloud services. You can read over it. What I'm trying to explain is that suppose, just an example, that you have launched a website, not the website launched, but just for instance, you have hosted a website called Wow. Okay, It's called WOW. And it has got a lot of things, lot of informations. Like you contained the contents over here, images, and also it's a social media platform where people can interact with each other whenever they want. So for that, you will have to buy a storage. Okay, you will personally have to buy a storage because there are people using your data, your website. So you will have to buy a storage right over here. And storage actually costs a lot. Actually, please, I would like to turn off my screen because, my voice would be tracking. Okay, so you have got this. And then what will happen next is that you are connected to your website. Something happens like there are people using your website. You have got 30,000 accounts into your website, created inside your website. So where you're going to store them? You're personally going to store them into the data, into the store space, into the data center. Where is your data center personally? And it's got a huge data. Okay. So what you're going to do is like you can buy a cloud platform at each and every country, or like you want like your data, your website to be hosted, at a platform, at a web platform where a lot of people from different countries and from your country as well can see the data, or you like access, you see the website, work over there, do anything like they want. So you are going to host it with Azure. Azure is a free cloud. It's a cloud platform where you have like products like, web hosting, web services, application services, and kinds of things. There are a lot of things. So basically, there are a lot of companies right now who have there are 85% of the global companies who use cloud storage, storing your data into the cloud. That's cloud, as you know, the name cloud is like abundant. There is no limit. There is no existence of that because you have your data stored virtually in one of the servers where you can access it anytime you want. And it's not so much costly. So it's called Azure. Microsoft has a platform, as a web cloud platform, which is called Microsoft Azure. And it's very interesting. You must dive into it and learn more about that. I'm going to share you this links and you can learn about that very much. So that's called Azure. Azure is a cloud platform, just for instance to you all, I'm trying to say. Second thing is, let's dive deep into Azure Orbitals. So what is Azure Orbital? Azure has got a lot of space. It's just taking the space, grabbing the space, Azure Orbital. So from here, what you're going to do is that we are going to give you an approach of just removing the ground stations. And you must think, oh my God, the ground stations, we are completely removing that because they are the major topic, or they are the major devices through which we are going to contact with our satellite, Aqua. So where I'm going to miss my Aqua, oh my God. So it's not like that. We are going to use Azure Orbital to contact to our satellite. Okay. So basically, what is the form of Azure? You know, it's a cloud platform. And Orbital, I have explained it right now. That is Orbital, this kind of thing, the orbits. Okay. It's just an example. But the real deep meaning of Azure Orbital is that you are just going to replace your data. Like if you have ground station, you are not going to install them. You are just focusing, you are creating an account on Azure Orbital, then click, and that's over. You can contact with your satellite in just blink of an eye, or like within an hour, because right now a lot of rocket scientists are wondering that how can we extract data, because extraction of data from space to the Earth is like a huge task. It's a huge task. We have got into our satellite, Aqua, we have got two things. That is an uplink and a downlink. Okay, this is U for uplink and this is D for downlink. The downlink helps us to, send the data back to Earth, and the uplink send the data from the Earth to the space, like to the satellite right over here. Okay, so here is the approach, our different approach to complete this. So this is only just a gist of what we are trying to say about Azure Orbital. You must be, a little bit confused. So let's see over here what we are actually going to do. So ground station as a service. Azure Orbital works as a ground station as a service. When we talk about as a service, we are removing the huge part, part which is very struggleful, like we have got a lot of messy documents right over here. So cloud as a service is that you focus on your work, and I will focus on what is that created. You created the mess over there. I will manage that. I will deploy it. I will do it by myself. I will do your work. Okay, that's something like that. And over here, we are doing like ground station as a service. We are like putting up as a service. We are like, we have our ground stations installed at somewhere else. We are not properly focusing on our ground station. We are just focusing on our satellite. And that's the main basic point of what is the ground stations talk about. Okay, so let's dive into what is the ground stations, what Azure Orbital actually does. So we have got our spacecraft that is Aqua. I'm taking this name twice, but just for instance, be aware that we have got our, spacecraft register over here that is named as Aqua. So I created an account at Azure Orbitals. I registered my spacecraft with all those frequencies, the orbit in which it is going around the Earth, and then I created a profile where it contains the TLE. The TLE is just a basic, just like on Earth, if we are going to grab a data of some particular thing, like if you want, here is a grid, right? You want the data of this particular thing. So they have got some basic TLE. It's a 2.00, 2.1 kind of thing. It's a huge data or the number which actually defines where actually your spacecraft or the satellite was launched or where it is presently. Okay, we create a contract profile with location and kind of thing, and then contact schedule. That is like when I really want my spacecraft to be like Earth rotates, and our Aqua is going at a speed of like it revolves around the Earth in just 19 minutes. Okay, so the Earth is also revolving and the satellite is also revolving. So we want at a direct place at which our satellite should give us the data from a particular data center. Okay, so we created that scheduled. It's like just the time of what I'm hosting the event. Like it's 4:30 p.m. I want my data to be delivered at India. I'm from India, so I will say I am India at 4:30 p.m. Okay, at 4:30 p.m. and then I will create a class and then click what we are going to know about in the later documents, and then I can grab my data right from here. It's so easy. It sounds a little bit like complicated, but when we're really working over it, it's quite easy for all those rocket scientists that are working, because you don't have to work over SQL tables and kinds of things. They are like huge mess, and you don't have to learn SQL, JavaScript, and kind of all those programming languages you actually learn. You just have to create a profile on Azure Orbital, and then go ahead with creating your account and then scheduling, and you can contact with your spacecraft at any time you want without focusing on the ground stations. Now, this is the basic thing right over going over here. We created an onboard spacecraft. We created a contact profile with Aqua. into the dashboard of Azure Orbital. The spacecraft and the contract profile will be created. Okay, and then we will schedule on which day or on which time do we really want our data to be transferred. That's the main basic point which we are going to discuss right over here. So this is the thing which it's a demo of Aqua. So you can just have a brief introduction of what it is. I hope the concepts are clear to you. If you have any kind of question, please feel free to raise your hands anytime, and I will be answering them. All right, so I don't see any of them raise hands, so I think I should go ahead. All right. Okay. So you got a question? Yes.
A question from our guest.
Also, would you like to unmute yourself and ask a question? Anyways, let's move ahead. I think they have just by mistake happened. You can lower your hand. So we have got this contact profile of Aqua. These are the resource groups. What we are going to do is like we connected the cloud profile with our orbital. Like our satellite plus the cloud profile is equal to your data. Like in mathematics, we do these kinds of things. But for a simple brief introduction is that we have got a subscription ID right over here. The auto track, that is the band, which band is actually forms, and then the time at which I want my data, maximum evaluation degree. This is the degree of what you know that antenna of our ground station is actually going to dance over there, like it's going to rotate from one to other place to grab the data for a particular time, right? So for that purpose, we are going to grab it over here. Okay, yeah, feel free to ask questions. And it's the location of Aqua at particular because it's a NASA space satellite particularly. It works over. So I would like to a little bit of definition. What Aqua does is that Aqua is a satellite of NASA. NASA owns it, and what it does is like, oh my God, what happened? No problem. What NASA has this Aqua satellite, and it is basically used for weather reports of a particular area. Weather reports, they are basically used for weather reports or weather data, weather evaluation kind of thing. If you want to have any kind of questions related to weather, or you want to know the weather of a particular city for around 5 hours, then it's going to help you out. It's a very interesting, its working is very interesting. I just walk over there. Just saw a little bit of videos, and feel free to watch them if you like. Okay, so here is the main basic thing going on. We created a profile with our Aqua. We gave the subscription ID. We created the maximum evaluation in degree, that is, it's going to turn around at 10 degrees whenever the satellite comes in contact with the ground station at our Azure data center. So where are these ground stations installed? We are not working to install those huge giant ground stations or those big disks. We are just giving that work to Azure. Okay, at Azure has a huge amount of data centers in different countries. So at that basis, Microsoft is going to install all these huge giant disks, and from that we only need to pay per minute. That is pay per minute. That is, you only need to go ahead, install create a contact profile on Azure Orbital, and then you can grab the data. You don't need to focus on where is the ground station, the network, the compactness of how the data will be, how the channels will be working, what is the frequency. No worry of that. You only go, say hi to your satellite, and then come back. That's as easy as I say. Trust me, it is.
Meg, we got some question from our attendee.
Yeah.
Yeah, they raised their hand. I'm not sure what question they're asking, so probably can ask them to unmute or ask their question.
For sure. So I got 2 hands. Janet, would you like to ask some question?
Yeah. You know, means you tell me that Aqua is one of the best satellite of NASA.
No, not that. We are not judging the satellite right over here. We are just saying that I named, because I love this word aqua. It's something related to the water. So I named my satellite like what we are right now doing a tour to space. We are going with this. We're taking a journey with our satellite, that is Aqua, to the space, and then I'm just taking an example of Aqua. Aqua is a satellite of NASA which works over weather conditions. It really focuses on weather conditions.
Okay, can you please tell me what is the functionality of Aqua? Why you choose it?
Basically, it's not just a functionality, because there are so many satellites. They have got from this small, just like, let me turn on my video. You have got this small satellite to this big satellite, right? Up to a level of a fridge, a small fridge. So basically, because I love this word aqua, and since I don't have my own satellite into my room, so I just want to a demo picture, which you can see right over here. So there was a satellite called Aqua. So I chose it for elaboration of what we are right now learning. I hope you understand.
Yeah.
It is clear now.
Cool.
Okay.
So also, by the way, we got several documentation introduction to Azure as well as Azure Orbital. And by the way, if you got any question about Aqua satellite, we got some explanation and documentation related to NASA. So you can check it out and to see if it can help you to figure out what you wanted to understand. And and by the way, if you wanted to ask any question, feel free to leave a comment down below in the comment section, and also raise your hand to reach us out. Cool. Let's move on.
All right. So Kanika, I got another question. So Kanika, would you like to unmute yourself and ask a question?
Yes, Megha, I have a question. So I want to know that Aqua is only made for NASA or other?
Basically, Aqua is a satellite. Okay, it's a satellite which NASA built. These satellites are human-made, like they are man-made satellites. So NASA, the people working in NASA, they actually made this satellite. So if it's my event, I would say I'm the organizer because I hosted this event. I can say that's the same thing happens with Aqua. The NASA owns that satellite Aqua just because it has, it has craters. So please feel free to unmute yourself and ask a question, brother.
Thank you, ma'am. So my first question is that what is the lifespan of this satellite?
So basically, the lifespan of these satellites are dependent on how much they are able to contact with the Earth. Till that, about Voyager 1, it is into the deep space and it still contacts sometimes. Okay, they have got around 3 to 4 years of lifespan. As an accurate, each and every, like for medicines, each medicine is made with an expiry date, not with that of space satellites. Sputnik 1, when it was launched, it fall into the Earth in just 1.5 years, something like that. It fall around so instantly that we can't say. So we can't actually judge the thing of how much the satellite is going to retain into the Earth.
And my second question is that what's next? What next when the satellite is of no use?
It goes into the out of the Earth. It is revolving and then it falls. Sometimes it happens like it is into the space and it creates a piece of junk. You can see it is of no use. But there
Okay,
are
ma'am.
parts of.
Okay, ma'am. My third question, that if it is a junk if it is a junk, then it can also destroy another satellite. So it can be dangerous. So what is
Yes,
the
for sure.
precaution?
For
What
sure.
is the precaution?
For that, we have communications, right? Each and every satellite consists of communication sensors. As soon as an asteroid, there are so many asteroids, just like the satellite. You said the example of satellites, but I would say we have got some asteroids somewhere over there. They work as a piece of junk, and somewhere they right over into the satellite. They can strike at any time. But for that, we actually made it in such a way that whenever an asteroid comes over, it can stop and rotate a little bit, just like in the movie you have seen.
Yeah.
Okay. By the way, if according to the question earlier I mentioned earlier, that we got some reference you can find related to space trash or space debris removal. There's company and some organization doing that, especially ESA, European Space Agency, as well as Astroscale, this company from Japan, is doing the space satellite removal. So if you guys are interested in that, there's a link in the meeting chat. Feel free to check it out. Yeah.
Awesome. Thank you very much.
And by the way,
one more thing, if you
cool.
Yeah, you can go ahead.
And by the way, there's a profile. I already posted a link to. If you guys are interested in Aqua Satellite, there's a mission profile and a very specific data related to Aqua Satellite from NASA website. So if you got interested in that, please just feel free to click the link and you can find out more. If you have any questions, feel free to bring it out. We are happy to try our best to answer. Yeah. Cool.
So I think questions are over. Or if you still have any question, you can unmute yourself and ask me. Anyways, just a simple thing of what he's my brother, he's asking questions. So just for instance, if you want to know about that, a rocket actually contains a eco-friendly thing, that is the gas tank. The boosters right over.
Any question?
I think
Cool.
Okay. Works fine. So, okay. So I was on this slide, I think.
Mm-hmm. Yeah.
Awesome.
Yeah.
Okay. I would like to go ahead and then right over here we have one more thing that, as I mentioned about the boosters in the right back. So, let me go back a little bit so that I can explain. briefly about. Okay, so over here, we have got these boosters. They are called, usable one. As soon as they fall, they at a span of like when the Earth, when the spacecraft or our satellite or our rocket is at a distance of 30,000 kilometers from the altitude, as an altitude of from the Earth's lower, I would say, the lithosphere as an initial. From there, when it is a distance of like 30,000 kilometers, they fall back. They have some kinds of, they are renewable, and they can be used in another spacecraft or another rocket as well. So NASA, not NASA only, there are a lot of organizations who have made these kinds of renewable resources as a part of a rocket so that we can use them once again. Now, by the way, I would like to go ahead with my present settings here, over here. So I explained you about these kinds of things already, about the aqua and all these kinds of evaluations and kinds of things. So let's move to the next one. So here, what we are going to do is that our satellite is going to strike. Our satellite is going to strike over right over here. Okay, it is going to come anytime. So this is the ground station at the Azure Data Center. Okay, it is over at the Azure Data Center. Azure, like Azure has some data centers all around the world. So they have installed some of the kind of ground stations. From there they access these all satellites data. Okay, because ground stations are very important. So, and here is the frequency, the RF input spectrum. RF means the radio frequency, because the data coming from the satellite, it's into the it's at a broadband speed from your broadband, like something like 35 Mbps and kind of thing, because it's a huge kind of data, huge amount of data, and it takes a lot of time. But since it's out of the Earth, it is on the space, so we want it is like it is in the radio frequency kind of spectrum. It is coming, and the data or the, channels or the frequency are like binded together at one speed. May it be telephonic data, mobile data, and like any kind of data. Channels are binded together, and this is just a layout. And they are just processed, these kinds of data, and are then processed according to their needs, and they are like processed, and then they are stored into Azure cloud storage. So what is the need? We're going to discuss later on, but here is that they are stored in the Azure, they are processed, like they need to be, these are some kind of information which need to be transformed into 0 and 1 classical bits, like 0 and 1, and they are then converted into pictures, pixels, and kinds of information, important information what the satellite has done. So let's know more. I know the time is like running, but I just want to finish it as soon as possible. So let's know more about. It's just a couple of slides over. The slides are about to get over. So here is our satellite, that is Aqua. It's revolving all around the Earth. This is the Azure ground station, orbital ground stations located at the Azure data center, and from there the data is going to store into the cloud, because the data is very huge, like 125 terabytes of data is coming from the space. So it is going to be, there is need that we will store these data into the cloud, and then we are going to attach the orbital services, that is our satellite, and then provide virtual network into the Azure services, you have seen these are just limited one, but that web hosting, cloud hosting, and then that's hosting one. And then we have got firewall protection because Azure has the best, security as for initials. And then we can use all those Azure services with our Orbital services. Like if I want to connect to if I want to have my own virtual machine, and over there I want to host my or run my satellites data, then I can do that. And even it's good at the Azure services contains of AI ML requirements. So that it is very important when we are doing about remote sensing. It's a part of spatial technology. You can go ahead and learn about that. So this data, which is coming into 01, it is further processed by Azure and then converted into a beautiful landscape image, and then it is given to you. So it's so easy to do that, all kinds of things. It's very interesting. You can go ahead and check it out about the documents. So what is the need? Why there is a need of getting these kinds of data, so much of storage costs? Because in near future there is a situation that in future we will launch like 25,000 satellites over the Earth's atmosphere, something like that. Yes, something approximate. I don't know if there is no zero. So for each data, for each per day, you have to get the amount is like this, and you will get the data like this. 280 terabyte of data per day. Can you think of from one satellite, from all those 25,000 satellites, we are going to get data around at a speed of 50.0 Mbps, and it is around 280 GB per day. So you can imagine we need a huge storage for that, because they are usable data. You must have seen, like, whenever you don't destroy all that data after a span of time. You need it. You need it one or the other time. So I would say that's the thing. And then cost, it's not going to cost a lot of things. So we are going to install the ground stations right over at Azure data centers, and a lot of things like cloud stations. And then you have got so many interesting things right on Azure. So you can use Azure data center, Azure Orbital as your use, because it's a need. You can see the need. So there is a small video. I would like to play that.
Throughout the ages, humanity has looked to the stars to understand our place in the universe. But how can what we do in space inspire us to solve the challenges we face here on Earth? Now more than ever, we need to find a new viewpoint to envision solutions for the most pressing challenges that face us as a species. Solving climate change, healing economic divides, educating new generations, connecting people around the world. Whatever your mission, it will take new technologies, partnerships, and ecosystems to harness the opportunities both on and off the planet. We're inspired to help you invent with purpose. Whether your needs are to communicate anywhere, design new satellite constellations, or just gather new insights on the world around you, Azure is the platform for your next mission. In the most challenging situations, we are called to elevate our perspective and deploy our collective creativity to solve our planet's problems.
So we got very important thing to say, that if you want to learn something new, since you learned a lot of things today about Azure Orbital, just for instance, you can go ahead with 30 days of learning challenge at Microsoft Cloud Skill Challenge. You will get 50% off on your NTC exam voucher. Since you know that they are paid exam vouchers, and they are very interesting and they are very knowledgeable. Once you go into that, you have to work over on cloud platforms. You will learn a lot of things about cloud, and then you can go ahead with Azure as your interesting thing, because you learn about Azure as an initial. They are very interesting. So I'll send you the link. Mark, would you like to send the links to each and everyone? And the Q&A session, I think it's about to get, because I answered each and every question right over here. So, if you get any question, feel free to ask us, or else you can leave. Thank you very much for joining us. If you have any kind of question, you can ask us.
Any questions so far?
That was so interesting, so amazing to have you all. Thank you very much for giving your 1 hour to us to learn anything, something new, which you must have not heard about that, but you learn. Because let's create a space for your knowledge next time, and you will learn a lot of things for the next time.
Yeah, cool.
Let's drive deep. Thank you very much for joining us.
Yeah, good to be here as well. And I believe that Azure is the next generation infrastructure for innovation. So if you have any idea or any solution that you want to build, I highly recommend you can start with Azure to take a look if there's any solution that you can collaborate with Microsoft. And also there's a larger opportunity you can get from Microsoft. So if you guys students, you can also get a student credit to use Azure for free. So yeah, very happy to be here to see all those people coming from around the world to join this event and also join this talk with us. Yeah, any question with Microsoft Azure as well as Azure Orbital or things related to space?
If you have any question, you can go ahead or you can leave the chat. Yeah. Thank you very much. It was very interesting to have you all right over here. And we really enjoyed those all questions, and these are kinds of information that we actually transferred to you. Very awesome. Thank you from Mark and my side. Thank you very much.
No queries. It is really a very interesting event, and I think we all are enjoy this event. Thank you so much, Megha. And really, it's a really awesome topic.
Thank you very much, Shannon. That was awesome to have such an enthusiastic student with us, through which we can, communicate, get answers, get questions, and all kinds of things.
Thank you, Megha, for hosting the event. It was such an interesting event.
Thank you very much, Achal.
Thank you, Megha, for a wonderful event.
Thanks, Kanika. Thank you very much.
Or if you have any suggestion or any idea for what we're going to host, first to please to comment down below. We can see if you provide any idea to us so that we can host more interesting event with you guys. Cool. So, any question or any idea or comments about what we're going to do?
No queries. Thank you.
No worry. Good to have you here.
You can leave the meeting. You can boot out of the meeting. Thank you very much.
Cool. Yeah. So.